Good day, viewers. I welcome you to today's episode of Learning with Olufisayo Study Point. Today we'll be talking about sine and cosine rule. The law of sine is generally used to find the unknown angle or side of a triangle. This law can be used if certain combination of measurements of a triangle are given. So in today's video, we'll be proving the sine and cosine rule. These are the sines and cosine rules. First of all, we need to prove the cosine rule. And for us to prove this rule, we need to consider a triangle. Let's denote here as A, here as B, and this as C. And of course, we have the height of the triangle. Let's denote the height as h. We know that the corresponding side of a triangle will be denoted in a lowercase letter. So here is the corresponding side of acute angle A. We have the lowercase letter A. Here is the corresponding side length of acute angle B. We denote it as lowercase letter b, and this last part as C. Of course, let's denote here as Y. We know that if the side length of A to Y is R, of course we know that side length of Y to B would be C minus R. For us to prove this rule, we need to consider angle ACY. Let's forget about this part of a triangle for now. We're talking about this part of a triangle. Now, I believe that we are familiar with what we call SOHCAHTOA. Sine A will be equals to opposite over hypotenuse. If we are considering the angle ACY, here becomes our adjacent, here is our opposite, and here is our hypotenuse. So we have sine A is equals to opposite, which happens to be h, over hypotenuse, that happens to be b. We need to cross multiply. So h multiplied by 1, we have h, equals b multiplied by sine A, we have b sine A. Let's denote this as equation 1. Talking about cos, we have cos A is equals to adjacent over hypotenuse. Adjacent over hypotenuse. We have R over B. As well, we need to cross multiply. In here we have R is equals to B cos A. Let's denote this as equation 2. Now we need to consider the other parts of this triangle. This angle CBY. I would like to take our mind back to what we call Pythagoras theorem. Pythagoras theorem states that the squared of the hypotenuse is equals to the squared of the sum of other two sides. That is, the squared of this side is equals to the sum of the squared of this side and this last side. We have c squared equals a squared plus b squared. Now, this happens to be our hypotenuse. We have a squared is equals to h squared plus c minus r squared. We have a squared equals h squared plus c minus r. C minus r, of course, is in squared. So we have a squared equals c multiplied by c will give us c squared. C multiplied by minus r will give us minus cr. This multiplied by this will give us minus cr. Minus r multiplied by minus r will give us plus r squared. Now we have a squared equals a squared plus c squared plus r squared minus 2cr. Let's denote this as equation 3. What we need to do now is to substitute equation 1 and 2 into equation 3. That is, we know the value of our h and r. We substitute the value of h and r in equation 3. We have a squared equals h squared, which is this, b sine a, and don't forget is in square, plus c squared plus our r, which is equation 2, b cos a squared minus 2. Here we have c, our r as well in equation 2, b cos a. So we have a squared is equals to b squared sine square a plus c squared plus b squared cos square a minus 2bc cos a. Now, we can bring these two guys together. That is, b squared sine a and b squared cos a. We have a squared is equals to b squared sine a plus b squared cos square a plus c squared minus 2bc cos a. So we need to factor out b squared because b is common to this part and of course this part. So we have a squared equals b squared sine square a plus cos square a plus c squared minus 2bc cos a. Now I would like to take our mind back to trigonometry identity, and the first identity is cos square a plus sine square a is equals to 1, meaning that everything here becomes 1. We have a squared equals b squared multiplied by 1 plus c squared minus 2bc cos a. Now we have a squared equals b squared times 1 will give us b squared plus c squared minus 2bc cos a. And this is the cosine rule in which we have here. Now we need to prove the sine rule. Sine A over A equals sine B over B. For us to prove this rule, we need to consider this part of the triangle. Also, we need to apply SOHCAHTOA, where we have sine A is equals to opposite over hypotenuse. Here is the opposite and here is the hypotenuse, that is H over B. We cross multiply as well. We have H equals sine H equals B sine A. For us to consider sine B, we need to as well look at the other side of the triangle, where we have sine B is equals to opposite over hypotenuse. Here is the opposite and here is the hypotenuse, H over A. We cross multiply as well, where we have H equals A sine B. If you look at these two equations, they are the same because H is equals to this and also H is equals to this, meaning that we can compare the two equations. H equals H. Now we have B sine A is equals to A sine B. The next step is to divide through by AB, where we have B sine A is equals to A sine B. We need to divide through by AB. AB. This cancel this and this cancel this. Therefore, we have sine A over A is equals to sine B over B. In this video, we've proved the sine and cosine rule. These rules are used to calculate the unknown angle or side of a triangle. Thank you for watching. Like and subscribe.